Alright, here we go. Geometry. We're back. Chapter 4, Section 1, Translations. Alright, if we look at this chessboard here, I slightly rearranged this because usually you have A, B, C, D down here, but I made it like a coordinate grid. Okay, so I take a knight. The knight can jump over other figures. He can go up 2 over 1. So he was down here and he went up there via going up 2 over 1. Now, I can write that as saying he went over 1, so plus 1, and he went up 2. The change in x was 1. The change in y was 2. Up 2 over 1. This arrow right here, directional arrow with its initiation point here and termination here, is called a vector. Okay, and it tells me change in x and change in y, much like a slope would tell you change in y over change in x, rise over run. Well, this we list like a coordinate, but change in x, change in y. Now notice that the knight didn't flip, didn't turn around or anything, didn't get mirrored. It just moved from here to there. It didn't change shape, didn't get larger or smaller. It just stayed the same, but it moved to a different place. That's called a translation. All right, here's an example. Translate triangle ABC using the vector -4 and 1. This is the change in x, change in y. So I could draw that vector saying -4, so horizontal change, or the horizontal component is -4, 1, 2, 3, 4 to the left, up 1. So I'm going to go from where we are now, C, to a new point. We call that new point C prime. So we make a little line like this, from C to C prime. Or I can just use the coordinates. So my coordinates for A, see, A is 4 and 3. My coordinates for B are 7 and 1. And my coordinates for C are 4 and 1. Now this is how I like to do it. I take the vector and I just write that underneath this statement. So -4 and 1. Same thing here. -4 and 1. And -4 and 1. So all I have to do now is tally this up. 4 minus 4 gives me 0 for A prime, and 3 plus 1 is 4. So if it's negative, just do whatever the sign is, minus, or if it's positive, 3 and 1. So we're basically just adding the vector. 7 minus 4, so that would be 3. And 1 plus 1 would be 2. That's B prime. And then C prime. 4 minus 4 is 0. 1 and 1 gives me 2. So those are my new coordinates. I already have that 0 and 2 coordinate. A is 0 and 4. And B is 3 and 2. So there's my new triangle. We call this the image. The one before the translation is called the pre-image. Now I could write this also in what's called a translation rule. So what we did here, we did x minus 4. So the translation rule, we would write like an ordered pair, and we're saying what happens to all the x values, and then I could just plug those in. So x minus 4, and then y plus 1. So basically what I just did, having the coordinates and the vector underneath, in component form. This, by the way, is called component form. I can write that as a translation rule, combining those two into one statement. So label your little graph. This is your pre-image, the original one. Before the translation, before is pre, and then the image is the one after the translation. It says write a rule for the translation. Okay, so that's what this is. The translation rule is x. What did we do? To the x we subtracted 4. To the y we added 1. All right. The term rigid motion, when I showed you the chessboard, that knight didn't change its shape, its size, it didn't flip around or do anything like that. That was a rigid motion. It preserves length and angle measure. So translation is a rigid motion. That's the translation postulate. So if you have a triangle and you translate that, the new angles are the same. The new sides are the same. So lengths are preserved and angles are preserved. The composition theorem, if we have a composition of translations, so that means I do one translation and then I do another translation, that's also a rigid motion, which means we don't change what we initially had. So it doesn't matter how many times you translate something, the original shape doesn't change. We preserve length and angle measure. So the composition would be from the first to the last shape. So that's the composition right here, from the PQ in blue to the P prime prime, I suppose, in green there. All right, performing a composition. There's a couple ways you can do that. You could do the whole thing once, do a translation, and then take your new values and do a second one. But in order to save time, what I like to do is combine these translations into one. So if they're given like this could be given in vector form. In component form, that would be 5 and -2. And in vector component form, this would be -4 and -2. Always does this with my 4s. Gotta be careful. There we go. So I could just tally these up and say 5 minus 4 is 1. -2 minus 2 is -4. So my translation from the original to the final, the composition, would be +1 minus 4. If you add 5 and then you subtract 4, you have a net addition of 1. If you subtract 2 and subtract another 2, you have a net difference of -4. Okay, you could do the same thing if you were just given the vectors. So tally these up and that's what you get. Alright, so now if you perform the composition doing one translation and then the second, you would do it twice and you'd end up here. However, if we do that in one, as we said, we had this adds up to 1 and this to -4 minus 4. -8 plus 1 is -7. 5 minus 4 is 1. So if I go from point R, 1 to the right, down 4, I end up at -7 and 1. Same thing here. I can do 1 minus 4, and I end up at -5 and 4. So I can do the whole thing in one step and save some time. -5 and 4. Unless they require you to show both, this is probably the faster and easier way to do it. Alright, and that's all for translations, folks. I will see you next time. Woohoo!